All right, welcome back to the deep dive. We always love getting requests from you all, and one that's been popping up a lot lately is this idea of really taking a philosophical approach.
Yeah, diving deep into the really big questions.
Exactly. And honestly, when we first saw that request act as philosophers, we were like, okay, that sounds cool, but what does that actually mean?
Right, like where do we even start?
But then we realized being a philosopher often means wrestling with those really fundamental concepts that we kind of take for granted in everyday life. And one of the most fundamental questions, maybe the most fundamental, is this: what is a cause?
Yeah, what does it even mean for one thing to cause something else?
It seems obvious at first, right? I hit the record button, we start recording, simple cause and effect.
Right, you flick a light switch, the light comes on, cause effect, easy.
But the more you think about it, the weirder it gets.
Oh, absolutely. It gets really slippery.
So, for this deep dive, we're going to do exactly that, get philosophical and explore this question of causation. And to guide us, we've got this fantastic resource, the Stanford Encyclopedia of Philosophy, entry on regularity and inferential theories of causation.
Which is quite a mouthful.
It is. But don't worry, we're not going to just read the whole entry word for word.
No, definitely not.
Our mission here is to sort of extract the most juicy, the most thought-provoking ideas from this dense philosophical landscape.
Yeah, kind of give you the highlights, the key insights, and hopefully leave you thinking about cause and effect in a whole new way.
All right, so the entry starts off by talking about regularity theories. And the big name that pops up right away is David Hume.
Ah, good old Hume.
So what's the basic idea here?
Well, for Hume, the core of causation is this. When we see something like A consistently followed by something like B, we start to think A causes B. It's all about observing those constant patterns.
So it's not just that one thing happens before another, it's that they happen together over and over.
Exactly. It's about seeing the same sequence play out again and again and again. Like you drop a glass, it shatters. You drop another glass, it shatters. You start to associate dropping with shattering.
Right, and Hume actually laid out three specific conditions for something to count as a cause. It has to come before the effect. That's temporal precedence. Makes sense.
Right. The cause can't come after the effect.
Then there's contiguity. The cause and effect need to be close together in space and time.
Yeah, close together, somehow connected.
And finally, and most importantly, there has to be this regularity. Every time we see something like the cause, it's followed by something like the effect. Not just once, not just twice, but consistently.
Like a reliable pattern. You see A, you expect B.
So these three ingredients, temporal precedence, contiguity, and constant conjunction, form what's called Humean regularity theory, or HRT.
Catchy, right?
Well, it's straightforward at least. But this view of causation, it leads to some pretty interesting implications. Like, for example, if a cause and effect have to be contiguous, that kind of rules out any idea of spooky action at a distance.
Right, no mysterious forces acting across empty space.
Everything needs a direct physical connection. And that condition about the cause coming before the effect, that's why we see causation as having a direction and asymmetry.
Yeah, A causes B, but B can't cause A in the same way because B would have to happen first.
Time only flows one way, at least in this understanding of causality.
Right, unless we're talking about, time travel paradoxes and all that fun stuff. But that's a whole other deep dive.
Definitely. Okay, the entry also mentions this word supervenience in the context of Humean regularity theory. What's that all about?
So supervenience in HRT, it means that these causal relationships, these regularities we observe, they aren't fundamental truths about the universe, like written into the fabric of reality. They depend on the specific details of what's going on at a more basic level, the arrangement of objects, the particular events.
So it's like the overall pattern depends entirely on the individual pieces making it up.
Right. If you change the pieces, you change the pattern. For Hume, it all boils down to those specific events and how they're arranged in space and time.
Okay. So when Hume says that one thing causes another, does he mean it has to, absolutely happen? Is the cause a necessary ingredient?
Not necessarily, or at least not in the way we might usually think. In HRT, the cause is considered a sufficient condition, meaning whenever we see it, we expect the effect.
Okay.
But it's not that the cause has this mysterious power to force the effect. It's just that, as a matter of observation, whenever we've seen this type of cause, this type of effect has followed.
So it's more about observed patterns than some deep underlying necessity.
Exactly. And Hume actually argued that This feeling we have of a necessary connection between cause and effect, like one thing must lead to another, it isn't something out there in the
And
world.
it's not
It's a habit of our
a
minds.
habit.
Yeah, an inferential habit. We see those patterns over and over, and our brains start to connect them in this really strong way.
So it's not like some law of the universe, it's just how our brains make sense of things.
Right. The feeling of must is coming from inside our heads, not from the objects themselves.
Okay, so that's a pretty big takeaway. What feels like a necessary connection is more about our mental processing than some objective feature of the universe.
Yeah, that's one of the more radical aspects of Hume's view.
Now, this regularity theory, this HRT, it has some advantages, right? It's fairly simple. It doesn't require us to believe in any weird hidden forces.
Yeah, no need to get into, like, deep metaphysics.
And it seems to offer a clear way to figure out what causes what. Observe what comes before, what happens nearby, and what patterns emerge.
Yeah, good old-fashioned observation.
But as the entry points out, HRT has its share of problems.
Oh, definitely. It's not a perfect theory by any means.
One issue that jumps out right away is this idea of sorting events into types.
Yeah, that's a tricky one.
I mean, how do we decide what makes one event like another? If we're talking about regularity between types of events, we need a way to group individual events into those types.
Right, we need some criteria, some way to say this falling domino is like that other falling domino.
And HRT doesn't really give us a clear answer to that.
No, not really. It's kind of left open.
And then there are those really unique one-off events. The entry gives the example of, a meteor wiping out the dinosaurs. That's not exactly a repeating pattern.
Yeah, that's the problem of singular causal relations.
Mhm.
It seems obvious that the meteor caused the extinction, even though we haven't seen like a regular series of giant meteor impacts wiping out entire species.
Right, so how does HRT account for those unique historical events if it's all about observing regularities?
Yeah, that's a tough one for HRT to explain.
And then there's the classic problem of regularity without causation.
Yes, the rooster crowing and the sunrise.
They happen together with almost perfect regularity, but we don't think the rooster is causing the sun to come up.
Right, they just happen to coincide, driven by some other underlying factor, the Earth's rotation, in this case.
And the entry also mentions the problem of joint effects of a common cause. Like, if event C causes both A and B, then A and B might happen regularly, but that doesn't mean A causes B.
Yeah, they're both just downstream consequences of C.
So regularity is a clue, but it's not the whole story.
Right. There's more to causation than just seeing things happen together over and over.
Okay, so recognizing these limitations, philosophers tried to refine this whole regularity theory idea. And one of the key thinkers in this effort was John Stuart Mill.
Yeah, Mill was all about trying to make the idea of regularity more precise, more useful.
He agreed that regularity was important, but he said it had to be the right kind of regularity, law-like regularity.
Meaning regularities that reflect the fundamental laws of nature. Like, gravity always works. That's not just a coincidence, that's a law.
Right. And Mill had a more detailed view of what a cause actually is.
He saw it as this whole package deal.
A package deal.
Yeah, a totality of present positive and absent negative factors that are together sufficient for the effect to happen.
So it's not just one thing, it's a whole set of things working together and some things not being there.
Right. And crucially, these things have to be connected by a law of nature. So it's not just any random set of events, it's a set of events that play out according to a more fundamental principle.
Which brings us to another big question. What is a law of nature?
Yeah, that's a deep one.
The entry mentions the best system account developed by Ramsey and Lewis as one way to approach this. What's the basic idea there?
Okay, imagine you're trying to create the most efficient, the most elegant description of the entire universe, like a universal rule book.
Okay.
You want a system that starts with a few really basic principles, axioms, and from those, you can logically deduce all the other truths about the world theorems.
Okay, like a really powerful, compact set of instructions for building the universe.
Right, and the best system is the one that balances simplicity with strength. A small number of principles, but able to explain a lot of stuff. The generalizations that are essential parts of any such best system, those are considered laws of nature.
So it's like the laws are the most fundamental regularities, the ones that make everything else make sense.
Yeah, and the source points out something really interesting here. So this way of defining laws might introduce an epistemic component, something related to our knowledge and understanding.
Oh, that sounds tricky.
Yeah, because while the regularities in the world are objective facts, The criteria we use to pick out which regularities are law-like, things like simplicity and explanatory power, well, those seem to depend at least partly on how we think and organize information.
So maybe the laws themselves aren't just made up in our heads, but the process of identifying them, of saying, this is a law that involves how our brains work.
Right. And if causation relies on these laws, then our understanding of cause and effect also has this connection to how we know things.
That's really interesting.
Yeah. It's pretty mind-bending when you think about it. Okay, ready for another philosophical mouthful?
Anyway, that
INUS conditions.
IUS conditions. What in the world?
I know, right? It sounds like a made-up word.
It does.
But it's actually an important concept developed by J.L. Mackie. It stands for insufficient but non-redundant part of an unnecessary but sufficient condition.
Okay, let's just break that down piece by piece because that was a lot.
Yeah, it's a lot to unpack.
So, insufficient.
That means a single factor on its own usually isn't enough to cause something. Like a lit match doesn't always cause a forest fire.
Right, you need dry wood, you need wind.
Exactly. Non-redundant means that this factor plays a unique role in a specific causal chain. Even though it's not sufficient on its own, it's essential to that particular way the effect happened.
Okay, and unnecessary but sufficient condition.
That means there are usually multiple ways to bring about the same outcome, so no single set of conditions is absolutely necessary. But each of those sets is, well, sufficient. If those conditions are met, the effect will happen.
I think I'm starting to see where this is going. The entry uses the example of a house burning down.
Perfect example. There are lots of things that could cause a house fire. A short circuit,
Or
lightning strike. Each of those could be part of a larger set of conditions that are sufficient for the fire.
so like a short circuit plus oxygen plus no sprinklers, that might be one sufficient set.
Exactly. And the short circuit is an INUS condition in that scenario.
Yeah.
It's not sufficient on its own, but it's a necessary part of that particular causal chain.
And the whole set of conditions isn't necessary because the fire could have started in a completely different way, like with the arsonist and a can of gasoline.
Right. And Mackie used these logical symbols like and, or, to represent these complex webs of causal possibilities.
So it's like different paths, different combinations, but each path can lead to the same outcome.
And one strength of this INUS approach is that it can account for causation even when there isn't a one-to-one, always the same result kind of regularity.
Because the short circuit doesn't always lead to a fire, but in the right context, it plays a crucial role.
Exactly. But even with INUS conditions, we still run into that problem of distinguishing genuine causes from things that are just joint effects of a common cause.
It's like the Manchester Hooters and the London workers.
Yeah. The Hooters going off in Manchester might seem like a non-redundant part of a sufficient condition for the workers in London leaving work, but it's not really a cause.
It's just that both events are caused by something else, the clock hitting 5 o'clock.
Right. And even Mackie himself struggled with this. He talked about needing some concept of causal priority to sort it out.
So even with all these refinements, regularity theories still have their limitations.
Yeah, they can only take us so far.
Which brings us to the second big category covered in the entry, inferential theories of causation.
Okay, so here's the shift. Instead of just focusing on patterns out there in the world, we start looking at how our minds reason about cause and effect.
So it's about the relationship between our knowledge and the idea of causation.
Exactly. And these inferential theories often try to build on, or even solve, the problems faced by the regularity theories.
The first type the entry discusses is the deductive nomological approach, often shortened to DN. And this approach has roots in a philosophical movement called logical empiricism.
Yeah, logical empiricists, they were big on grounding everything in logic and observation.
So no fuzzy concepts, no unprovable claims.
Right. Some of them were initially skeptical about causation, like, is it even a real thing? But thinkers like Ramsey started to connect it to this idea of believing in universal statements like, all flammable things burn.
Okay.
He called these variable hypotheticals. They're statements we believe are generally true, even though we can't test every single instance.
Right. And then there's the deductive nomological model of explanation developed by Hempel and Oppenheim. How did that tie into causation?
Well, the DN model says we explain an event by showing that it logically follows from a set of starting conditions and a set of general laws.
So the laws dictate what happens given the initial setup.
Right. And some thought, well, maybe this is how we understand causation too. If we can explain E by showing it follows from C and L, maybe that means C causes E.
So the cause is like the initial setup, and the laws are the rules of the game?
Right. But there are some problems with this simple DN account.
Oh, there always are, aren't there?
One is this symmetry problem. The DN model doesn't really capture the directionality of causation, the fact that causes come before effects.
Right, like I can use the laws of optics to explain the length of a shadow based on the height of the object and the angle of the sun, but that doesn't mean the shadow causes the object to be that height.
Exactly. Even though logically I could deduce the object's height if I knew the shadow length and the sun's angle, the DN model, in its basic form, doesn't distinguish between those two directions of reasoning.
Okay, so the simple DN model, it struggles to capture the flow of time, the asymmetry of cause and effect.
Yeah, and it also runs into trouble with those laws of coexistence that we talked about
Yeah.
earlier, like the relationship between a pendulum's length and its period. Knowing one explains the other, but we don't usually say the length causes the period in a dynamic, make-it-happen kind of way.
All right, so on to the next inferential approach. And this one involves something called ranking functions, developed by a philosopher named Spohn.
Okay, Spohn, he gets a little more technical.
I was afraid you were going to say that.
But the core idea is actually pretty intuitive. He's trying to capture how a cause changes our belief in its effect. Like, if we know the cause happened, how much more likely are we to believe the effect happened?
Okay.
He uses these things called ranking functions, which basically assign numerical values to different possible worlds based on how strongly we disbelieve them.
So a ranking function is kind of like a map of our beliefs, showing how plausible we think different scenarios are.
Exactly. A lower rank means less disbelief, meaning we think it's more likely. And from these ranking functions, Sohn derives something called a belief function that tells us the degree to which we believe a specific proposition.
Okay, so we've got these ranking functions, these belief functions, and now the entry brings up the idea of a reason.
Right. In Spohn's system, a reason is something that increases our belief in something else. So A is a reason for B if believing A makes us more likely to believe B.
Okay, and how does this connect to causation?
Well, Spohn says that C is a direct cause of E if C comes before E, and C is a reason for E, but without considering any information about C itself.
Okay, so it's about how our belief in E changes when we know about C, but within the context of what we already know about what happened before E.
Exactly, and non-direct causes are just chains of these direct causal links. Like, if A causes B and B causes C, then A is an indirect cause of C.
Makes sense. And the entry says Spohn's ranking theory can actually deal with that tricky problem of spurious causation, those correlations that aren't really causal.
Yeah, this is one of the really cool things about his system. Because if C is a common cause of F and F happens before E, his theory shows that F isn't actually a reason for E in the relevant context.
Meaning, once we know C happened, learning about F doesn't make us any more certain about E than we already were.
Exactly. Because the connection between F and E is explained by their shared cause, C. So Spohn's system can actually tell the difference between genuine causal links and just correlations due to a common cause.
That's pretty impressive. And this whole approach is considered inferential because it focuses on how our beliefs change when we get new information.
Right, which is, at its core, a process of inference. We're drawing conclusions, updating our beliefs based on what we know.
Okay, moving on to the next stop on our inferential journey, the strengthened Ramsey test developed by Andreas and Gunther.
All right, so the Ramsey test, it has a long history in philosophy. It's all about using hypothetical scenarios to figure out the truth of conditional statements, those if-then statements. So, the basic Ramsey test says, if I believe if A, then C. That means if I were to hypothetically assume A is true, I would also believe C is true. Like, if it rains, then the ground will be wet.
Okay, so if I can imagine A leading to C, then that statement is probably true.
Right. Now, Andreas and Gunther take this basic idea and they beef it up for causation.
They beef it up.
They add some extra conditions, make it more rigorous. They say that a statement like A because of C is true if, when we set aside our beliefs about whether A and C are actually true.
We sort of suspend judgment for a moment.
Exactly. We can logically infer A from C, given all our other background knowledge about the world.
So it's not just about what I would believe if I assumed C, it's about whether there's a solid logical connection between C and A, independent of what I currently believe about either of them.
Right, and they have some specific requirements for this.
Right.
C has to come before A in time. The inference has to go in a forward direction, meaning we're not inferring past events from future events.
Time still flows one way.
Right, and the inference can't rely on redundant generalizations or
Yeah.
contradict any of our other beliefs about the world.
And that condition about non-redundant generalizations, that sounds like their way of tackling that spurious causation problem again.
It is. They want to make sure the inference from C to A is direct, not just a side effect of some other relationship. Like in the Manchester Hooters example, any inference from the Manchester Hooters to the London workers leaving would probably involve some general statement about how clocks work, and that statement would itself be based on some more fundamental understanding of time and how those clocks are synchronized.
So the connection between the two events isn't direct, it's mediated by this more fundamental knowledge about how the system works.
Exactly.
Okay, let's move on to the next approach. And this one has a really interesting name, the chiretic account, developed by Strevens.
Chiretic. It sounds almost mystical.
It does, but it actually emphasizes the connection between causation and explanation.
Right. Strevens argues that any claim about causation is essentially based on a claim about causal explanation.
Like, to say A causes B is to say that A explains why B happened.
Exactly. And he uses this idea of causal models to define what makes an explanation causal explanation. A causal model is basically a description of how different factors relate to each other in a causal way.
Like a map of how causes and effects are linked.
Right. And a key idea in Strevens' theory is this thing called the explanatory kernel. Imagine you have a complete, accurate model of how some event E happened, a veridical causal model. The explanatory kernel for E is the smallest subset of that model that still logically entails E, meaning it's enough to guarantee that E happens.
Okay, so it's like the essential core of the explanation, stripped of any unnecessary details.
Right. And Strevens says this kernel has to be selected based on two criteria: generality and cohesion.
Generality meaning.
How widely applicable the explanation is to other situations. Like, an explanation that applies to lots of different types of window-breaking events is more general than one that only applies to a very specific type of window breaking.
And cohesion.
That's about how tightly interconnected the causal factors are within the explanation. So an explanatory kernel that involves a bunch of factors that are all working together in a tightly integrated way is more cohesive than one where the factors are kind of loosely connected.
Okay, so the kernel needs to be general, meaning it applies broadly, and cohesive, meaning the factors involved are tightly linked.
Right. And in Strevens' view, a cause of E is any factor that's part of some explanatory kernel for E.
It's a difference maker, something that's essential to the explanation.
Exactly. And this focus on generality, it has some interesting implications. It means we tend to describe causes in a more abstract way, focusing on the core features that really matter.
So instead of saying this specific brick broke this specific window, we might say that a rigid object of sufficient mass and velocity caused the window to break.
Right. Because that's the more general principle at work, and that's what's relevant for understanding the causal process.
Makes sense. Okay, the last category of inferential theories the entry covers is causal model approaches.
All right, these get a little more formal, a little more mathy.
I figured.
But the basic idea is to create these really precise, often visual representations of causal relationships.
Like diagrams and equations.
Exactly. People like Judea Pearl, Beckers and Vennikins, and Andreas Bochman have all developed different versions of this. Pearl's framework, for instance, uses structural equations and causal graphs to show how variables influence each other.
And the source mentions that these models are really good for doing counterfactual reasoning, those what-if questions about causation.
Yeah, like what would have happened if X hadn't occurred? Causal models can help us answer those questions in a rigorous way.
And some of these approaches, they don't even try to reduce causation to something else, like regularity or inference. They just take it as a fundamental concept.
Right, like causation is its own thing. It's a basic building block of how the world works.
So they're kind of sidestepping some of those earlier debates and just saying, let's start with the idea of causal influence and build from there.
Exactly. And by doing that, they can often avoid those problems of spurious correlation and other issues that tripped up the regularity theories.
Wow, that's been quite a journey. We've gone from simple regularities to complex systems of inference and formal causal models.
Yeah, it's been quite a ride.
And it's amazing how this seemingly basic question, what is a cause, has led to such a huge range of philosophical ideals.
It shows just how deep these questions can go, how much there is to explore even in the most everyday concepts.
And for you, our listener, who asked us to act as philosophers, I hope this deep dive has given you a taste of what that means.
It's about really digging into those fundamental questions, not taking anything for granted.
So next time you see something happen, think about those different lenses we've explored. Which one resonates with you? Does one theory seem to fit better than another in a particular situation?
It's not about finding the one right answer. It's about having these different tools for thinking about causation, for understanding how the world works.
And it leaves us with a final thought, maybe even more philosophical than the ones we've already tackled. Given all these different theories, all these different ways of understanding cause and effect,
Yeah.
is our understanding of cause ultimately a reflection of something real and objective out there in the universe, just waiting to be discovered?
Hmm.
Or is it more fundamentally about how our minds work, how we reason and make sense of things?
Or maybe it's both.
Maybe it's a bit of both.
Or maybe it's something else entirely.
Something we haven't even considered yet. That's
Yes.
something to keep pondering.
Definitely.
Thanks for joining us on this philosophical adventure. Until next time, keep diving deep.
And you keep thinking about those causes.